Hello everyone and welcome back. This is video 2-1. In module 2 we talk about title blocks, revision blocks, and things of that nature, and I wanted to take a few minutes just to kind of go over title blocks with you. In this module there's going to be 3 videos. One will be concerned with the title block, which you see located down here in the lower right hand corner of the drawing. The revision block, which will be up here in the upper right hand corner. And also we're going to talk about how to identify drawing zones. So the revision block will be in video 2-2 and drawing zones will be in video 2-3. So let's take a look at the title block. Now, as I mentioned in the text written for Module 2, there is a lot of information that can be found in a title block, and this is the very first place you should look the first time you examine a blueprint. The reason being is because some of the most important information on drawings is actually located right here in the title block. Things like the name of the organization that created the drawing. In this case, it would be Central Carolina. But it could be any company name. Whoever creates the drawings, that's what you'll find in there. You can also find other information, such as the scale of the drawing, which is very important. A lot of times a drawing is just way too big. The object that you're drawing is just way too big to fit on a drawing, so we apply a scale to shrink it down to fit on the drawing. More of that is listed in the course text. Drawn by would of course be the individual who created the drawing, in this case me. Typically all you're going to find in here is initials. It's very rare that you actually see somebody's name spelled out in the drawn by box or the checked by or the approved by. Ordinarily all you see is initials. Date, of course, would be the date the drawing was created. The drawing number will identify whether the drawing is just whether a drawing should be by itself or whether it's part of a set of drawings. Let's just say if you had 10 drawings that were describing a carburetor, this could be drawing 1 of 10 or 2 of 10 or 3, so on. Then down here you have the drawing title. Now in most cases this is just the name of the part that's shown on the drawing. If this were a drawing of a brake pad, then more than likely the drawing title would be simply brake pad. Now down here on the bottom we see CAD file. Most blueprints now are created with CAD, with computer-aided design software. Very, very few people still work by hand. Very few people still create drawings by hand. So what we do here is we add the location of the electronic file where it would be stored on a hard drive. If you work with an organization that's been using CAD for many years, they have thousands and thousands and thousands of CAD files. So locating a drawing can be very difficult if you don't know exactly where it's at. Here we see the projection symbol. Now the projection symbol it lets the print reader know if the drawing was created using first angle projection or third angle projection. First angle projection is used in, well, pretty much throughout Europe and the rest of the world. America and England are really about the only 2 countries that use third angle projection. These will be discussed later on when you get into other modules talking about how drawing views are arranged. Now here we see the sheet size. In most cases, the sheet size for a technical drawing is going to be either A, B, C, or D. A being the smallest sheet and D being the largest sheet. Here we have the initials of the individual who checked the drawing. A lot of information is found on technical drawings, and it's very rare for the person who created the drawing to be the one who checks their own work. It always helps to have someone else's eyes looking at the drawing, just making sure everything's the way it should be. Now, once the drawing is completed by the individual who draws it and checked by the checker, it goes to another individual to be approved. So really it's checked again. The approval is the final check. This is typically done by an engineer or an architect or a designer, somebody who's got lots of experience and really knows their stuff. Now, up here, we see the area that identifies the units of the drawing. Now, in America and in England, we work with just imperial units, just feet and inches usually. However, in most of the rest of the world, Europe and all of your Asian countries, they use the metric system. What's happened now that CAD has come along and electronic drawings and the internet, and we can share drawings faster throughout the world, a lot of times a drawing may be created in America, but it could be used in Germany, or a drawing could be created in Japan and it could be sent to America to be built. So it's important to have the units listed on the drawing, whichever system of measurement you're using. And here we see the tolerance area. Tolerances will be discussed in a later module. However, very simply, tolerances just determine how precise a part is made, and they also do a lot to affect the cost of the part. We'll learn more about that later. Material would of course be the material the part's made of, in this case aluminum. And finish actually refers to a machining process that will apply a surface finish to a part. In this case, finish all over, meaning that the part, whatever finish is applied to the part, is going to be applied to the entire part. Okay, everyone, thanks for watching.